Hey guys, welcome to this tutorial on Mössbauer spectroscopy, also known as the recordless nuclear resonance fluorescence of gamma radiation. So for this tutorial we're gonna work with iron 57 as the resonant nuclide. So this is the complex I'm working with in this tutorial, and please take into account the oxidation state of the iron nuclide. To sketch the complex I use Avogadro. So now that you have the XYZ file, you're gonna make a txt file with the commands for the optimization process. So this is what we're gonna do: XYZ file, the charge, the spin multiplicity, and the file we're extracting the information from, and the base is the name of the file we're gonna get in the output. What we gotta do first is open the terminal, and then let's check where we're at. Okay, so change the directory to desktop, ORCA, opt. Let's check the contents. Okay, so what you want to do is write the command ORCA, then tab commands tab.txt, and then this thing, and then out, the name you want for your output, opt complex, out, then hit enter. Now it's running. What you can do is open another shell and you do the same, right? Opt. Then you can put tail slash f, well, -f, then the name of your output, which is this one. See, here you see how ORCA is working, right? So now, as you may observe, we're looking for this message. ORCA terminated normally, and well, it lasted for almost an hour. And well, to further check that it was done correctly, you can go to the XYZ file that was generated, open it, and wait, and check if it's what you expected, which is like what I expected, because it's an octahedral complex. So yeah. Okay, so now that we have the optimized geometry, we have to proceed to write the code for the actual Mössbauer parameters calculation, right? So I took as reference the ones that are specified in the ORCA manual in page 297. Here you can observe. So I already wrote the code. It's this one. And okay, so as per usual, you go to the terminal, and here we have to change directory. We have to actually hop back. So now that we are in ORCA, we do ORCA tab.txt, again this thing, and out most parameters tutorial.out, and run. So now it's running, and well, the same thing here, 2.q, and then Control C. Now that we're here, we can do to go back. Well, I just realized that I didn't actually change directory, but I mean, I just did that, and here you can watch the iterations. But this calculation is gonna take a while. So what you can do is open a new window again, and here you don't have to change anything. You can use this command caffeinate and -t, and the number of seconds you want your computer to not sleep. So let's say 2 hours, and enter. So now your computer is not gonna sleep, and therefore it's gonna keep running. But I'm pretty much sure that calculation is gonna take around maybe 4 to 6 hours. So yeah, I mean, you have to take into account that. And as another note, you should also plug in your computer. Well, I'm working on my MacBook, so I have to plug it in to a power source, because otherwise it's gonna turn off and do nothing. Less time than I expected, 2 hours and 22 minutes. And well, we're always looking for this message, And well, we obtained the hyperfine parameters. So the tensor, the symmetry parameter, and rho, which corresponds to the electron density surrounding the nucleus. In this case, the iron 57 nuclide. So now all you gotta do is just plug in the value as I told you here, and run this thing. And it's 0.1 of isomeric shift,